All right, we are going to still work on these piecewise functions. This time I'm going to give you the equation and you are going to graph. So I made a little note on top. In class tomorrow, that will be Wednesday, you're going to do the following problems: 2, 4 through 9, 10 through 13. With me, we're going to do numbers 1 and 3, and then there's 2 of them on the back I want to show you. Make sure that you are pausing in between. I'm going to go kind of fast. Make sure you stop and understand before you kind of move on, okay? So things we need to remember before we get too far. Anything with a less than or greater than symbol gets an open circle. Everything else, this way, gets a greater than symbol. I'm actually going to do mine in marker so you can see. And another thing you may want is a ruler, because you want to make nice straight lines. So here's my ruler. Okay. So you need to do the following things. You need to make, in this case, we're going to make 2 t-tables. And we're making 2 because we have 2 functions. So one of these is going to be for the function y equals 5. That's this one right here. F of x equals 5, or y equals 5. The other one is y equals 1/2 x. So that's going to be my other t-table, or y equals 1/2 x. Okay, so the first step, make 2 t-tables. If you check out number 3, you'll notice we have 3 functions, so we'll make 3 t-tables. Then you need to start at the number given. And this is a little bit confusing because people see less than 0 and they want to pick numbers less than 0. But you need to start at 0, and now you need to pick some numbers that are less than 0. So I'm just going to do this. Over here, I'm going to start at 0. Again, whatever number's here is the one you start at. And I'm going to pick numbers bigger than. Okay, so pick some numbers. Yours could be different than mine, although you're probably copying me this time. That's okay. Next thing is to choose open circle or closed circle. So looking at this, I need an open circle here. This one is a closed circle. So that's kind of how I remind myself what to do. Then you're going to plug in the numbers. I'm going to write evaluate. You can write however you want. So this is my equation, y equals 5. Well, that's an easy one because that just means y always equals 5. I'm going to write the last step, this graph. So this one we're actually going to have to plug in. When I plug in 0, I get, for x, I get out 0. When I plug in 1, I get 1/2. When I plug in 2, I get 1. I skip down to plug this in here. Okay, when you graph, you need to be careful. They should never cross. Okay, this is one of the biggest mistakes I see, and they should have arrows on them. So let me show you. I'm going to plot this first point here, 0, 5, and I have an open circle there. So it's 0, 5, 1, 2, 3, 4, 5. I'm going to put a big open circle. Okay, that's where this one started. Then I'm plotting these other points here, and this is the way it continues. So if you think of it this way, it starts here with an open circle, and then it's moving to the left. So what I need to do when I draw is start directly at the open circle. I hope you guys see this. You can zoom in a little for you. And then I'm going to draw only to the left. Okay? I'm not going anywhere past my open circle. You will see that it touches my open circle, and then that's it. When I move over here, I'm going to do the same thing, except for a closed circle at 0, 0. Closed. Big dot. These dots have to be bigger. The rest don't really have to be very big. So 2 over 1 up, you'll see I just kind of put a normal dot. That's this point. 4 over 2 up is that dot. Again, I'm only moving to the right this time. So when I line my ruler up with my big closed circle and my dots here, I'm only going to draw an arrow like this. Now look, do these ever cross? No. Okay? So I've just plotted these functions. If you liked my color coding, this is my yellow line. And this is my pink line. Okay, make sure that you understand before you move on with me to number 3 that has 3 lines. All right, this one should have 3 t-tables. One of them is going to be for this first equation, which is y equals negative 2x minus 4. Okay, the next one is going to be for y equals 7. And the last one is going to be y equals 3/5 x plus 1. Okay, so 3 t-tables. We're going to start at the number given. And I'm going to put stop, because this one has a stop. And what do I mean by that? Get out my highlighters here. Our first one begins at -1. I know it says less than. You still need to write -1 here. And I want numbers less than -1, so pick some numbers. Doesn't matter. Pick 3 or 4. Okay, then you're good. The next one, it has a start and a stop. we are going to start at -1 and move towards +5. So I usually just pick numbers like this. Okay? Nothing too fancy. And then my last one begins at 5. That's the number they give us. And then I want numbers that are bigger. Now, I'm going to pick numbers that are divisible by 5 because of the fits. You could pick 6, 7, 8, 9, 10. I'm going to pick 5 and 10. And then I know any more than that is off my graph. But if you got decimals, that's okay too. I'm just trying to make it easier for myself. Okay, remember we need to choose now, open or closed circle. So we're going to go back here to this. At -1, I need an open circle. In my second one, I need a closed circle here and an open circle here. And in this last one, I need a closed circle. Okay, so now we can go ahead and plot our points. I'm going to do my blue line first, if you will. If I plug in -1, and you can do this in your calculator, -2 times -1 is +2, -4 is -2. -2 times -2 is +4, -4 is 0. 6 minus 4 is 2, and 8 minus 4 is 4. So here's mine, and I'm going to do this. Oops, you couldn't see some of that. And now I'm going to graph it. So at -1, -2, I should have one big open circle. The rest of them can be points. -2, 0. -3, 2. -4, 4. That should be enough. I grab my ruler. Okay, I'm going to start at the open dot, and I'm only going to move in the direction of my dots. Okay, only that direction. It should stop right at my open circle. Now, I'm going to do this table. No matter what, my answer should be 7, right? When y equals 7, everything is 7. So at -1, 7, I should have a closed circle. And at 5, 7, I should have an open circle. And you can connect all your dots in a straight line at y equals 7. And then the last one here, I'm going to plug in 5. 3 times 5 is 15. 15 divided by 5 is 3. 3 plus 1 is 4. You can pause here and do it in your calculator. So this one's going to be 30/5, which would be 6. 6 plus 1 is 7. So again, do it in your calculator. So then at 5 over 4 up, you're going to have a closed circle. And the next dot I have goes there. This is my final line. Okay, again, notice that my lines don't ever cross. So a big mistake made with piecewise functions is that you cross the lines. You need to make sure that when you start and stop at an x, you start and stop at an x. So like this x stops at -1. So it stops here. It never goes any farther. This one starts at -1 and stops at 5. This one starts at 5 and just keeps going in this direction. So that's something we need to be very careful of when we're doing these. Okay? Again, you need to pause, make sure your graph matches mine. Write down any questions that you have so that tomorrow you can ask them to me. Okay, this flipped classroom stuff won't work unless you're asking your neighbors and me questions after you watch the video. So what I need you to do now, though, is flip to the back side, because we have two different kinds of equations here. Okay, the first one is, this is called absolute value. Okay, so some of you may know this. Look at up here. It says plot at least 5 points. What happens is, if you don't plot enough points, you don't get a very good equation because this one makes the shape of a V. Okay, if you're not getting a V shape, try adding some points in one direction or the other to get a good V. You need the whole thing. So I'm going to pick 5 points, and I'm going to pick these, and I know these work. Remember, absolute value means, let me zoom out so we can see the whole thing. Absolute value means always positive. So when I plug -2, the absolute value of -2 is +2. 1, 0, 1, 2. And you should see now that this is probably going to turn around since the numbers repeat. So -2, +2, that kind of looks like this. Now, a pet peeve of mine is when people graph and then they just connect the dots. Okay? This graph is not complete if you do this. You need to continue on in both directions forever and ever, even if you didn't make dots there. Okay, so absolute value. So when you do these two, if you don't see it turning around, make sure you add some more points to your table. You might have to add more points up and down in your x direction. This one means add 3, then find the absolute value. Okay? This one means find the absolute value, then subtract 2. If you guys have Desmos on your phone, you can do this on Desmos to double check your work. You won't always have decimals, but the command for absolute value, I believe, is in the functions. And then miscellaneous ABS means absolute value. And you could just put absolute value of X, and you will see you get a nice graph there that looks like a V. So this is one way to check this one on Desmos. This other one I have started here is called the floor function or the round down function. Because no matter what number you pick, you're always going to round down. So we are going to make a table that has some decimals, and this one's a little bit confusing. So if I pick 0, I'm going to round down to 0. Let's say I pick 0.25, I round down to 0. 0.75, I round down to 0. 0.99, I round down to 0. Okay, as close as I can get to 0, I'm always going to round down to 0. So at 0, it's going to be a closed circle, but I can't get to 1. So basically, it's going to be an open circle on this end. So I'm going to show you what that looks like. I'm going to label every 2 of these to be 1 unit, just to give myself some more space. At 0, 0, I have a nice closed circle, and I can get as close as I can to this number 1, 0.999999999, and I will always round back down to 0. So it kind of looks like a barbell with a closed circle on this end and an open circle on this end. If I make another table, let's say with 1, I would round down to 1. It's a whole number. But every time I keep going here, I round down to 1. Any decimal number I pick up until 2 rounds down to 1. So at 1, 1, I have a closed circle. Over here I have an open circle and a barbell. Kind of looks like that barbell. If you want to check your work, this one's a little confusing. If you want to check your work, again in Desmos, if you go to the function menu, it is the floor function. So you can see here, the only problem with Desmos is that it doesn't like give me like the closed circle and the open circle, but if you trace along here, let's see if I can do it. Oh, it gives you that, so that's not really accurate, right? You can trace along here, and you can't see it because it's underneath my finger, and see what numbers always round down to 1. And then it stops and moves. I can see it right there stopping, you just can't see it under my finger, and then moves to the next thing. Okay, so this round down function is pretty cool. And it makes these steps where you can see it's changing, getting really, really close to 3. Oh, and then I jump up to 3. Because as close as I can get, and I can't get to 3 unless I actually round up to 3. Okay? So those are the 4 types of problems. I want you to be able to work on the rest of these in class tomorrow, so any of these. Please take some good notes on here and be ready to ask questions tomorrow. Thanks, guys.